This is EGME-331 Solid Mechanics Prerequisite video series. In this video, we'll be reviewing force vector. So what is a force vector? A force vector is a representation of a force that has both magnitude and direction. This is opposed to simply giving the magnitude of the force, which is called the scalar quantity. Now, a vector is typically represented by an arrow in the direction of the force and with a length proportional to the force magnitude. A major feature of the force vector is that they can be broken into components according to the application of the force. The vector components are usually perpendicular to each other, although they can also be in a parallelogram configuration. Although we can designate a force simply as a number or a scalar quantity, it is generally more useful to state it as a vector, where you could include the direction of the force. So instead of saying that the force is 5 newtons, you would say something like the force is 5 newtons towards the ground. Now, what are force vector components? It's often useful to break the force into its components. Now, we have two most popular ways. One is the perpendicular vector components, or we have the parallelogram vector components. An advantage of using perpendicular vector component is that you can use the Pythagorean theory, which is a square plus b square is equal to c square, to determine the length of the components. In other times, we would be using the parallelogram vector components for the force vector. Now, the force can be expressed also as a sum of vectors. That means you can add two or more force vectors that are at angles with respect to each other to create a new force vector. An example is if the force is moving an object in a given direction, and let's say a wind applies a force on it at another angle, the new motion will be as if the force was applied in that direction. So that's the case where you can express force as a sum of vectors.